Today, I will introduce our paper named Is Bigger Always Better? An Empirical Study on Efficient Architectures for Star Transfer and Beyond. Let's begin with an observation. Most existing star transfer algorithms use ImageNet pre-trained VG19 as a feature extractor, which is comparably big and inefficient. Here comes questions. Is bigger always better? Can we find efficient alternatives? Can we make efficient networks have a comparable performance with VG19? In answering these questions, we made the following contributions. We conducted an empirical study to find efficient networks replacing VG19. We proposed a channel pruning method to improve the efficiency of networks, and we proposed a new star transfer model to improve the star transfer performance of efficient network architectures. In our user study, we compared the star transfer performance of different architectures. We find that a few networks like ResNet 34, Inception v3, MobileNet v2, and GoogLeNet have similar performance of VG19, both in visual and human evaluation. But the efficiency is very different. For example, GoogLeNet has 10 times fewer G-flops than VG19. In this way, we choose to use GoogLeNet as an efficient backbone to replace VG19 star transfer. We also propose to make the efficient network even faster. Our method is based on an observation that there are a few empty channels in feature maps of networks pre-trained on ImageNet. So we proposed a simple channel pruning method to remove empty channels in networks, and we theoretically prove that removing empty channels has no influence to star transfer performance. In addition to that, we propose a sandwich swap transfer module to improve the performance of efficient networking in star transfer. The proposed method consists of 2 add-in layer and 1 star swap layer in between, and we use add-in layer to transfer global appearance and star swap layer to transfer file details. And we also use feature aggregation, which performs star transfer in different level features, and it is very similar to multi-level sterilization, but is more efficient. In our experimental comparison, we use both visual and quantitative comparison based on SSIM and user study to demonstrate the effectiveness of our method. In visual comparison, we can see that our method has comparable star transfer quality, but the content preservation ability is much better than all existing state-of-the-art methods. In terms of the efficiency, our method is better than all existing methods. We also conduct an ablation study. In top left image, we show the star transfer results with and without removing empty channels. We can see the star transfer results is almost identical, which shows that removing empty channels has almost no influence to the star transfer performance, but makes the networks more efficient. In bottom left image, we remove each component of the proposed method, and we can see the performance drops significantly, which shows that the proposed component, each component is important in our method. The proposed sandwich swap subtransforms enables transfer color and texture from different images, which enables a new application. We call it dual star transfer. That's all for our paper. Thank you.